Hello all, welcome to this tutorial session 8 on the course Structural Analysis. Today we will first discuss, we will give a brief recap of week 8 lectures, followed by the problems related to statically indeterminate trusses. We will discuss in this session about flexibility method, in this session it will be a brief discussion. In the next week we will discuss it in detail, how the flexibility matrix will be created and all. Today we will just see how those components of flexibility matrix are created, for truss members and for simple structures, truss structures mainly. We will discuss about trusses today. So for simple truss structure having lesser degree of static indeterminacy, preferably 1, how to write the flexibility component, from a given matrix there will be some components or some inputs, and for DSI 1 this will be 1 cross 1 matrix, so just one component we have to write. For that it is a matrix containing one component only. So followed by what is force method we will see, and steps to solve statically indeterminate trusses using method of consistent deformation, which is nothing but a type of force method in itself. So let us move forward. So let us come first to the force method. Before starting force method, I want to ask, in the previous week, that is week 7, we have discussed degree of static indeterminacy and kinematic indeterminacy of a structure and how to determine it using both formula and using the first principle also. So are you comfortable now to how to calculate degree of static indeterminacy and kinematic indeterminacy, which is also called degrees of freedom of the structure?
Yes,
Because
sir, yes.
if that won't if you won't get a clarity there, those methods, because indirectly you have to apply that DSI and KI for every structure from now onwards till the last week. So if that is not clear, everywhere you will face trouble. So is that clear?
Yes, sir.
Yes, yes, sir.
Oh. So force method. Force method, in this method, I am just highlighting all those important points because you must have gone through week 8 lectures and there sir has discussed in detail. So I am not going in detail, otherwise we won't be able to solve some problems, which is the main motto of this class. So in this force method, as the name suggests, forces will be the unknowns. So the first step is forces are unknown in this method. Second, in this method, compatibility conditions of the structure are taken into account and are satisfied to calculate the unknowns, that is the forces. We will see how those compatibility conditions are written or taken into account to solve statically indeterminate problems. Now, this is the most important point. Preferably, see the last word first. It is preferably if the degree of static indeterminacy is less than the kinematic indeterminacy or degrees of freedom, then the force method is applicable. It is not like that if kinematic indeterminacy will be more, then we can't use force method. We can use force method, but the calculation time will increase and it is not viable to do, because if kinematic indeterminacy, suppose for a structure is 3 and degrees of static indeterminacy is 2, then here unknowns are 2, which are in terms of forces. Here unknowns are 3, which are in terms of displacements. That may be theta and delta, here F, force. That may be force and movement. So, if the number of unknowns will be more, then you have to solve more number of equations, which is more cumbersome. So, if the degrees of static indeterminacy is less, then force method is applicable, because we will have less number of equations and less number of unknowns to solve, and which will be easier comparatively. So, it has been written preferably if DSI is less compared to the other counterpart of the structure, then force method is preferable. Next, there are various force methods, such as method of consistent deformation, strain energy method, free movement method, flexibility matrix method, and column analogy method. Remember all those names, because in any examination, when you are going, they may give you 4 names or 5 names, and they may ask, identify the different force methods from the given options, or identify the different stiffness method, force method and displacement method, or which is also known as stiffness method, from the given bunch of methods. So method of consistent deformation is first type of force method. Second is the strain energy method. Third is the 3 movement method or Clapeyron method of 3 movement. Fourth is the flexibility matrix method. Fifth one is the column analogy method. So today our main focus will be on this first method, that is method of consistent deformation, and that too for which type of problem? Truss problems. Today we will only discuss how to solve statically indeterminate trusses using force method, that is method of consistent deformation, which is a type of force method. So, how to analyze statically indeterminate trusses by method of consistent deformation. So, the first step is, as usual, you have to find the degree of static indeterminacy of the given truss structure, that we have discussed in week 7. And you are quite comfortable now, hopefully, to calculate the DSI of truss structure. Second, identify the redundant of the structure. Suppose this is a truss. Now, see, A is also in joint A, there is a hinge support. In joint F, there is also a hinge support. And we know when there will be a hinge support, translational movement is not possible. So, 2 reactions will come, one in vertical direction and the other one in horizontal direction. Here also, 2 reactions will come, one in vertical direction, one in horizontal direction. Now, check. We have for 2D structure, we have three equations of static equilibrium. Now, but when you will check degree of static indeterminacy externally for this truss, I am not going to internal degree of static indeterminacy as of now, just for means clarifying this step 2, I am just showing how this step 2 will be applicable. Now, degree of static indeterminacy from external means external degree of static indeterminacy. In this case, what will be the DSI external?
One, sir.
Yeah, 1. So, this one equation, if someone will, one equation means if from these 4 forces, someone will give you one force, means known value, then you can completely analyze the stress. So that one force needs to be determined. How that will be determined? First, in using this method of consistent deformation, we will determine. First, you need to identify this TSI of the truss. Like you have identified here, TSI is 1. Now, check. Identify the redundant of the truss. Now, you have to draw a primary structure such that its DSI value is 0 as well as it is stable. So, I am drawing a primary structure. You just see. I am considering Fy as redundant. See, if you will take Fy as redundant, in force method, you have to release this Fy, means along this vertical direction at joint F, there won't be any force. Release Fy. So when you will release that force, you will get the modified joint will be like this, having a vertical roller. Now check here, it will be AY, this is AX, and here one Fx will be. Fy we have released. Now check AX, AY and Fx. There are 3 reactions and we have 3 equations of equilibrium. Now this is a primary structure. This is a primary structure which you can analyze. So we have identified Fy as a redundant. In this way, you have to release one force, not one force. For this case, since the DSI was 1, so I have released one redundant force. If DSI will be more, then you have to release that many number of forces or movements. In truss, there won't be any movement. There will be only forces. So you have to release, to be specific, as we are discussing trusses. So we have to release that many number of forces equal to the DSI and analyze the structure. That structure will be termed as primary structure. Now, tell me, if I will apply some load like this, is this structure stable? From visual inspection, you just tell, is this structure stable or not? And there is some vertical load also here and here also.
No, sir. No. Unstable.
Because now see, why unstable? If there are vertical loads, hinge, this is a hinge. and hinge can rotate, means there is no resistance against movement. So see my hand, this is a hinge, suppose I have to keep like this. This is hinge support, and there is a vertical roller. Means along this it cannot move, but vertically it can move. And if you are applying some load vertically about A, it will try to rotate completely, and it cannot resist those vertical loads as well as the horizontal loads which will try to rotate it. It cannot resist. So Fy as redundant is not making sense because the entire structure which is primary in nature is becoming unstable. So second, let us take Fx as our redundant. If you will take Fx as your redundant, then what type of support will come at this joint F? What type of joint will come? Just remove Fx and tell me what type of joint I should apply here such that our primary structure will be done. What happened?
Don't know, sir.
Check. Hinge. When you are providing a hinge, how many reactions you are getting? You are getting 2 reactions. Reaction means what? Just understand. If you are applying some load and this is a structure, let it be any kind of structure. This point, apart from rotation, it cannot move neither in x direction nor in y direction. And we are least bothered about z direction because it is a 2D structure now. So z direction is ruled out. It cannot move in x direction and y direction. Now, since we are releasing Fx, means there is no force along Fx. So it can move along that horizontal direction. So which type of support if you will apply, then you will get a movement along horizontal direction but not along vertical direction. Simple. Apply a roller. Now
Roller
check.
support.
Now check. Fx is released.
Yes, sir. Yes.
Now Fx is released, and any type of load when it will come, it has the potential to resist. See, if those horizontal loads are coming, hinge will try to resist. If vertical loads are coming, both roller and heel will resist by giving some reaction, support reaction vertically. As well as hinge support will provide horizontal reaction, which will take care of those horizontal forces that is coming on this truss structure. Now this is the primary structure we have built for this truss, statically indeterminate truss. So for this we have identified the redundant. Redundant is Fx. So our step 2 is done. Step 3, what I have said, the redundant should be wisely identified such that the structure remains stable overally. Like check the first one, the structure is unstable. So this node is getting violated for this first primary structure. So this cannot be our primary structure. And second one, if you will check, the node is getting validated and all our assumptions are okay. So the second one can be our good estimate of primary structure for this given truss after removal of redundant force. Now, remove all those redundants to form a primary structure which should be stable and statically determined. So we have removed that redundant fx and we have made a primary structure which is statically determinate in nature and stable as well. Now, come to this fifth one. Apply unit load and calculate the force in each member. Now, see, when this Fx is released, here you have to apply a unit load. You can apply in any direction. So I have applied rightward and that unit is, load is unity, means the weight is unit. Now we have applied unit load and calculate force in each member. Now, first of all, you have to make a primary structure. Since primary structure is statically determinate, so by using method of joints or sections, as we have discussed in previous week, most probably in week 3, you can use those methods to determine all those member forces because it is statically determinate, so you can use it directly. After calculating all those member forces, you remove all those external force. Like these are all external force. You remove all those external force from the structure and apply one unit load in that place along that direction where you have taken the redundant and released them. So Fx is released or Fx is taken as redundant. So in that direction, you can apply in rightward or leftward. That is up to you. Means there will be a change in sign only. But at that point or at that joint only, you have to apply that unit load. Once that unit load is applied, you again calculate that the forces in each member. That forces we have discussed while calculating the deflection of joints in truss members. That force system is called as K force system. And P force system represents forces due to external load. If you are not getting it, just go back after the class and check. In week 3 or week 4, we have discussed how to determine deflection of joints in statically determinate truss. So first you determine P force system for the primary structure, then remove all those external loads, apply unit load, then determine all those member force, store it as K force system. After this is done, apply necessary compatibility condition. This is the most important part you need to understand here. Now, compatibility condition. Check. This joint F, can it move in horizontal direction? Quick,
Yes,
quick.
sir. Yes, sir.
It can move in horizontal direction.
Joint F.
Yeah.
Yes, sir.
There is a hinge.
Joint F or A.
F. This joint.
No, sir, no.
Yeah.
I
It
I
cannot
thought in
move
the
in X direction, neither it can move in Y direction. Okay.
okay, okay.
But from primary structure, this joint can
Uh,
move in X direction or not, horizontal
yes,
direction
sir.
or not. It can move. So under these external loads, there will be some displacement. Let us say delta external load. Due to external load, there is a displacement along X direction, that is delta. Now, when you remove all those forces, external forces, and you are applying 1 unit load, due to this 1 unit load, this joint will try to move or not.
Yes, sir.
So I am writing as delta U. And from compatibility, can you write delta E plus delta U should be equal to 0? Compatibility should always be written taking into account the main structure.
Oh,
Now, tell me, can you write delta E, that is displacement of joint F, EF I am writing, delta UF. Displacement of joint F due to external load is delta EF. That is written for primary structure. Delta UF is also written for primary structure, but the compatibility is always written for the main structure. Now tell me, this F point cannot move in horizontal direction, but when you come to this primary structure, under external load also it can move along X direction, and due to this 1 unit load also, which is applied along that direction, it can move. So when you will combine those things, that should be equal to 0, because in the main structure, this point F is not going anywhere. So this is the compatibility condition. Till this point, is it clear or not?
yes, sir. Yes.
If this is clear, now we can directly solve some problems, and it will get more, you will get more clarity once we start solving some problems. So let us directly move to problems.
Sir,
Now,
in delta U, hello, one
yeah,
second.
yeah.
Sir, delta U, you will always be considered for a primary structure.
Yeah, everything will, this deflection, how at this point will there be any deflection?
No, sir, no.
So for these things you have to write for primary structure, but the compatibility condition will be taken care by the main structure.
Okay.
Means you will get more clarity once we start solving some problem.
Okay, okay.
Now check this question. Here they are asking to determine this member force in AD of the following truss for all members. Modulus of elasticity is given as 100 GPa and area is 200 mm square. Now, step 1. Calculate. What to calculate?
Degree of static indeterminacy.
Yeah. So, what is the value?
3, sir.
Not external. I am asking for total. You said 3 for degree of static indeterminacy external. but I am asking for the entire structure. What is the degree of static indeterminacy?
Okay.
Here I have considered external to means give you a insight how this method works. Otherwise, it might contain more TSI also. In that case, you have to again release all those forces. If DSI is more, then you have to release all those forces and apply these complete steps again in the similar fashion. And we have questions of multiple DSI also, and we will solve it and see how that is done in subsequent slides.
Total DSI will be 1.
So M plus R minus 2J.
Minus
That
2J.
is the formula. So M is 3. Reactions are 2 into 3 minus 2 into joints are 1, 2, 3, 4. So 9 minus 8, 1. So degree of static indeterminacy is 1. Now check degree of static indeterminacy external. You said R minus 3, that is 6 minus 3 is 3. So DSI internal, that is means that I am calculating just for the sake of calculation. Those are not needed. One point I have to make, that's why I am calculating. So 1 minus 3. So 1 minus 3 is minus 2. Correct? Till this point it is okay, right?
Yes, sir.
Yeah. Now check. Internal degree of static indeterminacy is minus 2. That means internally the structure is statically determinate, but externally the structure is statically indeterminate. So in this case, you have to identify one external support reaction which will be taken as redundant such that the entire structure, which is now statically indeterminate, will be converted to a statically determinate structure as our primary structure, following which two conditions? It should be statically determinate and at the same time it should be stable enough. So now check. Here there are two forces. Here also there are two forces. Here also there are two unknown forces. Now, can you tell me which reacts if this is AY, AX, BX, BY, CX, CY, then which reaction should we take as redundant? Such that our structure will become statically determinate. Anyhow, it will become statically determinate, but it might become unstable. So remember that while you are doing a primary structure, just give a visual inspection if under that given loading condition, if the structure entirely or overall it is stable or not. If it is not stable, then your answer will surely be wrong. If that is stable, then anyhow your answer will be correct. Now tell me, which force should be considered as redundant?
BX.
BX.
B, sir. B.
Sorry, which one?
BX.
This one, right? BX.
Yes, sir. BX.
Yeah. So you draw. If you are telling BX and at the same time BY is enough such that you can calculate all those reaction forces easily. because at times your structure might be stable, but calculation of the reaction will take enormous amount of time. So you have to be wise enough while making the primary structure, and it will come by practice and experience. And there is no alternate.
Sorry, sir, VY.
If you will release, sorry. If you will release Bx, your structure will become like this.
Yes, sorry.
You are getting now how I am changing those supports as per our need to convert our main structure to primary structure. Now,
Yes, sir.
now check. If you are taking this structure, this is statically determinate and stable. But now, what point I have made, the same problem will arise, that you will now let us write the equations of static equilibrium and see what problems we are getting. If we won't see the problems, then we won't think how the question can be solved from different aspects. Now check. From equations of static equilibrium, we can write Ax plus Cx will be equal to 30. Correct?
Yes, sir.
Now tell me, when we are doing summation of Fy equal to 0, what we will get? Tell me, quickly tell me. There is
AY
no
plus
such
VY
rocket
plus
science involved here.
20 kilonewton.
Correct?
Yes, sir.
Now what you can do, you can take summation of movement about point C equal to 0. Let us do. Now tell me what will be the equation? AY, what will be the lever arm?
AY into 4
Yeah.
plus
And
BY.
I am writing clockwise to be positive. Every movement, clockwise movement are taken as positive.
Okay, sir. Okay.
Plus
AY BY into 2
BY into 2. Okay.
minus 20 into 2
Minus 20 into 2. Okay.
plus 30 into 4.
Plus 30 or minus 30?
Let me see. Minus 30 into 4. Counterclockwise.
Now, when if you are facing problem to take movement about a point, just think. You go and stand there at that joint where about which you are taking the movement. Now, you stand here and see a 30 kilonewton. You have a pen or you have something. You are standing here and 30 kilonewton is acting like this. And with your hand, you want to push that 30 kilonewton that side. So, in which way your hand is getting rotated when you are standing at C? Anti-clockwise, right?
Anti-clockwise.
Yeah. Similarly, 20 kilonewton is vertical, downward. B at C, take your hand and try to apply that 20 kilonewton in downward direction. In which way your hand is rotating about point C?
Clockwise.
Clockwise.
For you, it's anti-clockwise.
It is means you do and see.
Yes, sir. Yes.
Don't just see me and tell.
Okay, okay. No, no, sir, I got. I just mistake.
This is equation 3. Now check.
But still we are getting two unknowns.
Still you are getting two unknowns, and if you try to means from this equation, if you want to simplify it, you will get ay as a function of by or vice versa.
Yes, sir,
So
yes.
you will try to substitute it here. Then again also you are getting two unknowns, and anyway, if you will do summation of movement about A and B also and simplify it, you will end up getting this equation again and again. So this thing will come with practice, and there is no other option, and I am even helpless to help you in this matter. How to and means construct a primary structure. This will come with practice. So for this case, I am considering by to be redundant, and let us draw the primary structure considering by as redundant. If you will draw, if you will take by as redundant, how that supported b will be modified or changed? I have shown you. Now it's your turn to tell me how this support will be modified.
It will be act as a roller,
Which type of roller?
horizontal in vertical direction.
Yeah, this way.
Yes, sir, yes.
This was 20 kilonewton.
Uh,
This was 30 kilonewton.
okay. So first I have told correct.
That will happen.
Uh, okay, okay, okay.
Now, this is the primary structure. Now, here the unknowns are ax, ay, bx, cy, and cx. Now let us write the equations of static equilibrium again for this primary structure. Summation of fx equal to 0 if you will do ax plus bx plus cx equal to 30. Summation of fy equal to 0 will be ay plus cy will be equal to 20. Now let us take summation of movement about point C or A. Which point you want to see? C or A? Let us now take A. Now tell me the equation for when we will write summation of movement about point A.
Minus cy into divided means 4
Hmm.
plus 20 into 2.
Hmm.
Then 30 will be minus 30 into 4.
So you will get CY as minus. You will get 20 into 240 minus 120 by 4. So minus 80 by 4 minus 20 kilonewton. Now see, for this primary structure, how easily you are getting all those support reaction. But for that primary structure, though it is stable, but it will be cumbersome to calculate all those support reaction and member. But when you will take this primary structure, your work is getting quicker and easy. So now we got Cy to be minus 20 kilonewton. So when you will put Cy to be minus 20 here, you will get Ay as 40 kilonewton.
40 kilonewton.
So you got Ay, you got Cy. We got Ay, we got Cy. Now it's turn for horizontal. Let us go to joint B now. Now let us draw the free body diagram for joint B. Here, Px is acting like this and FBD is acting like this. So from here, when you will do summation of Fx equal to 0 and summation of Fy equal to 0, for this case you will get FBD is 0 and means FBD is a 0 force member and Bx equal to 0. So you got Bx equal to 0, Ay is 40 and Cy is minus 20 now. And this is 0 force member you got. Now go to joint D directly. When you will go to joint D, now see, this is 20 kilonewton, this is 30 kilonewton, and there are two forces, and this angle will be same because they are symmetric, theta. Now tell me if this is theta, this was 4 meter, 2 meter. This length was 2 meter and height was 4 meter. I'm writing it here. Now tell me cos theta will be how much? And sin theta will be how much? I am writing it here because we have to use it. All those trigonometric functions values. What will be cos theta? You're getting or not?
Yes, sir. Yes. Cos theta will be 2 by root 20 and
Cos theta
sorry,
will be
4 by root 20 and sine will be 2 by root 20.
yeah. Now this force will be FAD and this force will be FCDAD. Now see summation of Fx equal to 0 when you will do. This will be FAD sin theta minus FAD sin theta plus FCD sin theta minus 30 will be equal to 0. And when you will do summation of Fy equal to 0, you will get FAD cos theta plus FCD cos theta will be means minus FAD cos theta because upward positive we generally take and rightward positive for horizontal case we generally minus FAD minus FCD will be equal to 20. Till this point, all those equations are correct. Means you are getting.
Yes, sir.
Now when you will solve these two equations, I am writing it directly because I have the solution. FAD you will get as minus 44.71 kilonewton and FCD you will get as 22.36 kilonewton. Now you got all those P force members. Means P force system member force you got. This P force system due to force on applied on the structure due to external load. That force system is called as P force system, and we got all those member forces as of now. So we have three members. This member, the member force is 0, that is 0 force member. FAD is minus 44.71 and FCD is 22.36. Now, let me add one more slide. Now, the third step is to calculate all those K force system member forces. Now your primary structure was like this. This was A, this was D, this was E, C. And now apply 1 unit load at that point along that direction in which direction you have chosen your redundant force. So we have chosen By as our redundant. So vertical, either way means vertically upward and downward, that's your choice. The only change will be there in plus and minus. Magnitude wise, the value will be same. So apply unit load here. Removing all those external loads acting or the external forces acting on the truss structure. Now, this we have made. Now, for this, again, you have to calculate all those member forces. Now, again, you have to write summation of fx equal to 0. What you will get? Ax plus bx plus cx equal to 0. Similarly, summation of fy equal to 0, you will get ay plus 1 plus cy equal to 0. So there are two equations. Now, let us do summation of moment about c equal to 0. Tell me, ay into lever arm will be 4.
4.
Plus 1 into
2.
any other thing will come?
No, sir.
Minus 1 by 2. So you are getting ay to be minus 1 by 2. Now, come to this joint B. Anyway, ay is not required. We have calculated anyway. Let us now come to joint B. What will be the free body diagram? See, this is 1. This is Bx. And one member force, that FBD will come. Now, tell me, when you will do summation of fx equal to 0, what you will get? Px to be 0. When you will do summation of fy equal to 0, what you will get? FBD plus 1 plus FBD equal to 0 means FBD is minus. Correct?
Yes, sir.
Now go to joint D. Now in joint D, you have FBD to be -1. So if this is -1, then this direction will be 1. Then this will be FAD. This will be FCD. And those are theta angles we have already determined. Now, can you write, when you will write summation of fx equal to 0, you will see FAD sin theta will be equal to FCD sin theta, and theta are same, so sin theta will be same, means FAD is equal to FCD. Now same thing, when you will write summation of Fy equal to 0, you will see FAD cos theta minus. I am writing downward to be positive now, because anyhow minus plus will be managed. Plus FCD cos theta will be equal to 1. Now, from this equation, you got FAD equal to FCD. So 2FAD cos theta will be equal to 1. From here, you will get FAD equal to 1 by 2 into, it was 4 by root 20, right? 4 by root 20. So root 20 can be further simplified by 2 root 5. So you will get root 5 by 4. So FAD, this FBD you got as -1. FAD you got root 5 by 4. What about FCD? It will be root 5 by 4 because FAD equal to FCD. So you got all those member force in K force system. Now you draw a table. Now you draw a table. Now member, their lengths, their axial rigidity, LAE, and that P4 system what I was talking of, and that K4 system. P4 system is due to external loads on the primary structure. K4 system is due to, after removing all those external loads, applying that unit load at that given position. What are the member force? That will be termed as K4 system. Now, then now length is done, AE is done, P is done. Let us note down members are AD, BD, CD. Length of AD is root 20 or 2 root 5. So root 20. CD is also root 20. BD is 4 meter. All those lengths are in meter. Area we have 200 mm square. Modulus of elasticity we have 100 GPa. 100, right? GPa.
Yes.
So
10 to the
AE
power.
will be 100 into 10 power 9 by 10 power 6 into 10 power -3. 10 power 9 because I have converted GPa into Newton per meter square. Now to convert Newton per meter square to Newton per mm square, I have divided by 10 power 6. Now I am converting again into kilonewton per mm square. So 10 power -3. So now you have kilonewton per mm square. So it is 100 into area is 200 mm square. So mm square will be deleted. So you will get 200 into 100 or 20,000 kilonewton. So for all those members, AE is constant. Now, write the P force members. For AD, it was minus 44.71 we got. For BD, it was 0 force member. For CD, it was 22.36. Now, K force member we recently got. For AD, it was root 5 by 4. For CD, it was root 5 by 4. And for BD, it was minus. Now, for this primary structure, check the main structure. This B point, if you will see, will it move in vertical direction? No, it won't move in vertical direction. But as soon as you come to primary structure, you can see that under this given load or the loading condition, it can move in vertical direction. Okay, under this given load, it can move in vertical direction and you can calculate it using the method of virtual work, and that will be equal to this unit load you have applied here, that is 1, that is virtual load. So 1 into delta, if delta P or delta V only here, 1 into delta V is the external virtual work done, and that will be equal to summation of K into PL by AE. PL by AE is the real displacement or change in length occurring for each member under the actual loading condition, and this K is the virtual forces coming due to this virtual external load. So from here you will get delta V to be summation of K PL by AE.
Sir, please once more. From starting. Means
okay. In week 3, we have discussed the concept of method of virtual work. So in the method of virtual work, it states that external virtual work done will be equal to internal virtual work done.
yes, sir.
And you know work done is force into displacement. Correct?
Yes, sir.
Under given length. So now, in this case, when you are applying this 1 unit load, okay, this is your 1 unit load was initially present there or not?
Yes, sir.
It was not present. It was virtual. You are applying it.
Yes, sir. Yes.
Yeah. So this is virtual load. But under this virtual load, when once you applied, the displacement corresponding to that will be real. You can visualize really that when you are applying that 1 unit load, there will be corresponding real displacement occurring in the structure.
Yes, sir.
So let that displacement be delta V. What I have written there in the top corner. So force into corresponding displacement along that direction will be the external virtual work done. And that
Yes,
should
sir.
be equal to the internal virtual work done. So internal virtual work done will be what? The internal member forces acting on each and every member. So when you are applying this 1 unit load, due to application of 1 unit load, some member forces means forces will be developed or generated in those members AD And remaining members, like we have calculated for AD, it is root 5 by 4. For CD also it is equal, and for BD is -1. Under this unit load only. So these are also internal virtual forces. So Ki is the internal virtual forces due to application of external virtual unit load at that given joint. Till this point it is clear?
Yes, sir. Yes, yes.
Now this Ki is done. Now there is some. Now see, this one was virtual. So due to this virtual forces are coming, this is also virtual, but this one was real. So corresponding to this, some real deflections will be developed due to external load, that will be termed as PL by AE. Because you know, axial members, when you will give a load P, the deflection delta will be PL by AE. That you know. So PL by AE, or more generally PL by AE of I, and that I will be summation over all those members, I equal to 1 to, for in this case, for example, it will be 3. Now you got. So from this, you will calculate directly delta V value.
Okay.
Now, if you want more clarity, then go and check the earlier lecture on virtual work method. That in my YouTube channel only, you will find it. I have discussed there in detail, complete 2 hours. We have discussed enough problems. You will get more clarity. Okay.
Okay.
Now, this is K into PL by A. Okay. Now check. K is this, P is this, L is this, A is this. So you have to find the value of KPL by AE, because you have to find this part, and that will be the real displacement at that joint. So now you check, this will be how much? Can you tell the value?
Okay. Okay. I'm calculating.
Let me check if I have.
Minus 5.58 into 10 to the power minus 3.
You calculate and give me in terms of by AE, means something by AE, because AE is constant. So while summation, this will be
Oh,
deducted from both numerator
okay.
and denominator.
Okay.
So something by AE, you just tell me.
Minus 111.77 by AE.
Minus 111.78.
0.77.
Okay. This
Okay.
will be 0 by AE, and
Hmm.
this will be 55.9 by AE. Okay. So when you will do summation, because for total deflection at that point, you have to do summation over all the members. So summation of KPL by AE, you will get 55.9 by AE minus. Okay. You got?
Yes, sir.
You got it, right? Till this point.
Yes, sir. Yes, sir.
Yeah. Now, one more column will come. I am writing it here. That will be K square, K into KL by A. And this is nothing but the flexibility component for this case. Check. Now, remove all those external force. This K into KL by AE gives us, check, flexibility means when you are applying 1 unit load, what is the corresponding displacement at that joint? So means if this is a P joint, so FBA, which is flexibility, or FAA only now, it gives displacement at A due to unit load applied at joint A. So now see, you have removed all those external force and applied 1 unit load. So for this 1 unit load, member forces are developed, and due to this 1 unit load only, what will be the deflection? That will be KL by A. If the member forces are stored in K force system, it will be KL by A. Now check. K into KL by A. So you calculate this, you will get 1.397 for this AD, means just square it, K square into L. K square into L, you will get this by A. Or similarly, it will be 4 by A, and this will be also 1.397 by A. So overall, you will get 6.79 by A. Now, you are telling when we are applying this 1 unit load, we are getting this much of deflection. But if actually this 1 unit load is not real, this is virtual. So how much load or force is acting at this joint B? That is By. What is our redundant? If By equal to 1, then what we have calculated, that will be the deflection. If By is something we don't know, and we have applied in place of By, that is 1. So that won't give us the real deflection, that will give us the virtual deflection. Or due to not virtual, it is like under this 1 unit load, what is the deflection at this joint? But we have to calculate under this By load, what will be the deflection. So when you will multiply this By into this 1 unit, means deflection occurred due to 1 unit load, multiplied by that By amount, you will get the actual displacement that is occurring due to By. Correct?
Yes, sir. Yes.
Now, in real structure, see, this point is not going anywhere. And after removal due to external load, we are getting deflection as this. So minus 55.9 by AE is the deflection at that point due to external load. And this 6.79 by AE is deflection at that point due to unit load at that point, which is called as nothing but flexibility.
Okay, sir. But in the second member,
Yeah.
how it comes 4 by A? Okay,
Minus
okay.
1
Sorry.
square into L.
Sorry,
L means 4.
sir.
So
Sorry.
for unit load, it is this. But do you have unit load? It is not unit load. We have By force. So when you multiply By with this displacement occurred due to unit load, you will get the exact displacement that will be occurring if By will be acting at that point. And that is, when you sum it up, that comes from compatibility. That By into this plus this component due to external will be equal to 0. From here, you will get By as 8.2 kilonewton. Okay. And one thing to note here is you are getting By to be positive. Positive means in which direction you are taking that 1 unit load, that loading direction is correct, and your By will act in upward direction, and its magnitude will be 8.2 kilonewton in upward direction. Now, once you got this By value, you can calculate all other things, because now it has become statically determinate structure. You got it?
Yes, sir. Yes, yes.
Now,
Really?
if
Means we have to
By,
carefully. Okay, okay.
if By you got to 8.2
8 point.
kilonewton,
Hmm.
now tell me what can be done. Ay plus Cy plus 8.2, you will write as 20 kilonewton. Okay. Okay or not?
Yes, sir. Yes.
Yeah. And you can write Ax plus Bx plus Cx equal to 30 kilonewton, and we are least bothered about this equation. Now, when you go to this joint B, see 8.2 kilonewton is acting upward, Bx is acting like this, and FBD, and this FBD will be the
0.
real force or real internal force or member force of this real structure. Till this point, what we have calculated, FBD, KBD, that are related to primary structure and not that are not real forces of those members. Now, Bx you will get here as 0 when you will do summation of Fx equal to 0. Now, summation of Fy equal to 0 when you will do, you will get FBD as minus 8.2 kilonewton. What do we have to find? Found AD. Now, once you are done with FBD, so this member force you got. Now you just go to joint D. Here, minus 8.2 means 8.2 upward will be, and again FAD, FCD, theta, theta, and 20 kilonewton, here 30 kilonewton. Now, you can write summation of Fx equal to 0. Just see FAD sin theta minus FAD sin theta minus 30 FCD sin theta minus FAD sin theta minus 30 will be equal to 0. And similarly, when you will write for summation of Fy equal to 0, you will get 8.2 minus 20 minus FAD plus FCD sin theta, sorry, cos theta will be equal to 0. Now, when you will solve these two equations, you will get FAD and FCD. And I am writing it directly. FAD will be equal to minus 40.11 kilonewton. So option C is the correct answer, and minus represent compressive. Okay. Now you tell me what you want to tell. If you have any query, you can get it clarified now. You are having any query, then let me know. No doubt. Now we will do all those problems quickly without going into such details. Now here you have to calculate the horizontal reaction at support C of the following truss, for E and A are constant here also. Now see, DSI of the structure is, members are 5, reaction is 4, minus joints are 4, so 4 into 2, that will be 8. DSI is 1. And since we have to calculate the horizontal reaction at support C, just modify the structure to form the primary structure like this. This is 30 kilonewton. This is 20 kilonewton. This is 4 meter, 4 meter, and height is 4 meter. I am releasing this CX as redundant. I am taking CX as redundant. Now check. This is primary structure which is stable and determinate also. Now A, B, C, D. Now you can calculate all those reactions AX, AY, CY. That's it. Now you do summation of Fy equal to 0, you will get Ay plus Cy equal to 20 plus 30. When you will do summation of Fx equal to 0, you will get Ax equal to 0. So it is 0. Now, when you will do summation of movement about point C equal to 0, it will be Ay into 8 minus 50 into 4 equal to 0. So Ay equal to 25, 50 by 2, 25 kilonewton. So that means Ay will be equal to 25 kilonewton and Cy will be also equal to 25 kilonewton. Now come to this joint B. When you draw for joint B, this is 30 kilonewton. This is FBA. This is FBC. And this is FBD. So here FBD you will get as 30 kilonewton. Come to joint A. This is 0. This is 25. This is FAB. This is FAD. And this is, let this be theta, and that will be equal to 45 degree. So this is theta. So you just write summation of Fy equal to 0, you will get FAD cos 45 is 1 by root 2 plus 25 will be equal to 0. Means FAD is minus 25 root 2 kilonewton. Similarly, summation of F x equal to 0, rightward positive, you are writing F, you will get FAB plus FAD cos theta. FAB plus FAD cos theta will be equal to 0. So FAD we got. So FAB plus FAD is minus 25 root 2 into cos theta is 45, so 1 by root 2. So FAB is 25 kilonewton. Let me check if we are getting it right. We got AB to be 25 kilonewton. Now we got AB, and from here you can write FBA equal to FBC, and we got FBA AB equal to 25 kilonewton. So we got this member force, this member force, this member force, and this member. From symmetry, you can write FAT will be equal to FCD, or else you can take this joint and you can see this is 25, PC is 25, and this is FCD. So when you will do FCD by root 2, means summation of vertical forces will be equal to 0. So FCD cos theta or FCD sin theta. If this is theta, FCD sin theta plus 25 will be equal to 0. So FCD you will get minus 25 root 2. So this is also minus 25 root 2. So member force, that is P force system, you got. Now, similarly, remove all those external loads and apply the unit load in place of the redundant. How your this is A, B, D. Now apply one unit load in this direction. Now check when you will go to this joint B and draw the FBD, you will find when you will do summation of Fy equal to 0, you will get FBD is 0. So this is a 0 force member. When you will go to joint D, here this is one member force coming, and this is one member force coming. So when you will do take components, and you will see that both FDA is 0 and FCD is 0. So these are also 0 force member. Now come to joint C. When you will come to joint C, here one unit force is acting. Here reaction will come. This is 0 force member, so I am not showing, or let this be 0 force member, and FBC or KBC. For this it will be KBC and this. So when you will do summation of Fy equal to 0, you will get Cy to be 0 and KBC will be 1. So this is 0, KBC is 1, and from this you can see FBA will be equal to FPC. So this is also 1. And now when you will every member force is determined, so no need to go to joint A. So our P force system is done, K force system is done. Now draw the table, apply the compatibility and get the redundant value, redundant force value.
Okay.
Now members length AE. Now K into PL by AE and K square L by AE. That's it. Now, what is A value? Anyway, it will get deducted. We'll keep it in terms of A only. So members are AB, BC, AD, BD, CD. Length are in meter. AE will be in kilonewton. AB length is 4 meter, BC length is 4 meter, BD length is 4 meter, AD length. AD 4 will be 4 root 2. 4 root 2, 4 root 2, all are in meters. Now AE I am not calculating. So AE is constant throughout, so no need. Let that be AE. Now, one more thing, P and K force system we have to take. Now tell me what are the P member forces? For AB, it was 25 kilonewton under external load for primary structure. For BC, it is 25. For AD, it is minus 25 root 2.
Root 2.
This is 30. This is minus 25 root 2. Correct?
Yes, sir.
Now, K force system, you see, every member force is 0. Means CD 0, AD 0,
0.
BD B. This is B.
0, 0.
0.
BD 0.
BC is 1, AB is 1.
AB is 1.
So when you will multiply it, all these things will be 0. The only thing that will be left over is the first two
Yes, sir.
components. These two components. Now check. KPL by A. KP is 25, L is 4. So 25 into 4, 100 by A.
A.
This is also 25 into 400 into 100 by A. K square L by A. K square is 1 square, L is 4. So 4 by A. 4 by A. You sum it up. Summation of KPL by A. It will be 200 by A. Because now I am writing in terms of AE because AE is constant for all the members. If A and E varies, then you have to, if A and E are different for all the members, then you have to incorporate AE here only, calculate the absolute values of KPL by AE for each members and then add up, not in terms of AE, but in absolute value terms. Put A value, E value at each and every place and calculate the numerical absolute value. Similarly,
yes,
this K square L by AE will become
8 by A.
Now tell me, see the main structure.
Yes, sir.
This point C, there is a hinge. So, will hinge allow horizontal deflection? Means horizontal movement or deflection will be allowed?
No, sir.
It won't be allowed. So, compatibility will be written as when under this under this external load, there is some deflection in the primary structure. Under this unit load also, there is some deflection in the primary structure. But when you club these two, that should be equal to 0. Because the main structure hinge won't allow any deflection in the horizontal direction. So you can write 200 by AE, that is due to deflection of joint C due to external load, plus 8 by AE. 8 by AE was due to deflection at point C due to unit load at C. But this unit load, is it real or virtual? This is
It is virtual
virtual.
load, but displacement is real.
Our main force is Cx, which
Yes,
is
sir.
the redundant. So when you will
Yes, sir.
multiply this Cx with this displacement, and that you will sum it up to 0, because hinge won't allow any horizontal movement. This will satisfy, this equation is coming from compatibility and will satisfy the compatibility of the main structure. Now from here, what you will get, Cx as 200 by 8,
Minus
that is
25
nothing but 20 minus 25 kilonewton.
or
Here
completely.
minus 25 represents in which direction your one you have taken. That direction is wrong and your direction should be opposite, and your value of Cx or the absolute magnitude of Cx is 25 kilonewton leftward, not rightward, it will be leftward. So once you got this Cx, you got the horizontal support reaction. So your answer is 25 kilonewton.
Kilonewton.
So any doubt you are having?
No, sir, no.
Yeah. Okay.
Means everything we have to carefully incorporate. Otherwise,
Yeah.
otherwise it will be
Otherwise,
mistake at one.
there is
Yes,
a
sir.
huge chance that you
Sir.
will fumble and create some mistake somewhere
Yes,
or the
sir.
other.
If one point I have done mistake, then everything will be got wrong.
Yeah. Now let us come to this question. Now, same the means thing, the steps will remain same throughout for each and every question. Now,
Okay, sir.
see for this question here, this is a interesting question. Means here there you have to observe carefully. Tell me the DSI value.
PSI M will be M डाला 6 R3 DSI will be 1.
1. Now, 1 means we have to identify one redundant.
Yes, sir. Yes.
Can you tell DSI external for this case?
0. Internal means
1. So now, tell me which reaction we can take as
redundant.
redundant. That is the main question. If you get that chunk, then after that the question is simple, like the previous ones we have done. Tell me.
Means if we whatever we have to incorporate, we have to do at B point because there is a hint. If we just sir, we have to give a redundant at BX direction.
BX direction.
Means in
Means you
roller.
want to release BX, right?
Yes, sir. Yes.
You want to release this force, this reaction.
No, in By direction.
This reaction.
Yes. The release means we have to keep it in the horizontal roller won't be in horizontal direction. The horizontal roller will be in vertical direction, so that the structure will keep it as it is.
Means you are telling we'll give a roller like this.
Yeah.
Then check. What to check? That's a major question. Check. Under this 25 kilonewton load, the structure will move like this. Means it will try to move like this. 25 kilonewton will try to rotate, and that joint B will roll horizontally. And this is unstable state of the structure. We cannot do like this.
So if we apply in vertical direction, then it will also go downward.
That is the main thing here in this problem you have to understand. See, if DSI external is 0, so externally the structure is determinate. You don't have any scope of giving a redundant or introducing a redundant in the external joints. In this case, the internal indeterminacy is there. So you have to identify one member in which you can tell that that member force is unity by removing that member. Means here member force will be taken as redundant. So since we have to calculate the for force in member AD, so let us remove AD and that will be our primary structure. Means now our primary structure will be like this. We have removed AD. 25 kilonewton is acting like this. See, here AX will come. Here AX, sorry, BX and BY will come. A, B, C, D, A. Okay. Now, you
So
check.
please write the statement for as a note. I mean, whatever you have said means for this case.
If external DSI is 0, we don't have any scope of ascertaining any redundant from the reactions, that is external reactions. But the redundant will be taken as a member force from the truss members. You got it, na?
Yes,
now
yes.
check. This is our primary structure and this is stable also. Now, 25 kilonewton is acting downward, so By will be 25 kilonewton. So vertically, all those reactions got stabilized. Now, By and external load will try to rotate the truss in clockwise manner. So this AX and BX will be such that they will try to resist that rotation. So if you will give BX in this direction and AX in this direction, and both magnitude will be 25 kilonewton, separated by the same distance, because those are 3 meter, 3 meter. So this vertically also 25 kilonewton is separated by 3 meter, and this 25 kilonewton, those are reaction forces are also separated by distance of 3 meter, and they are forming a anti-clockwise couple. So that clockwise couple formed by this vertical reaction is resist there, means it got resisted by these horizontal forces in anti-clockwise manner. Now the complete structure is statically, means it is in static mode.
Okay.
Now we got all those reactions. Now see, when you will come to joint D and you draw 25 kilonewton FDC FBD. Now you see, when you will do summation of Fx equal to 0, you will get FBD as 0. And FDC will be minus 25 kilonewton upon doing summation of Fy equal to 0. So this is minus 25 kilonewton, this is 0. Now come to this point, this joint A. Similarly, summation of Fx will give you FAC will be minus 25 and this member force will be 0. Now check joint C. This is minus 25. Minus 25 means 25 inward. Again, this is also minus 25 means 25 inward. And this is F, but F, B, C. Now, and this is 45 degree. And this is also 45 degree. So F, B, C, cos 45. I am doing summation of Fy equal to 0. Will be equal to 25. So FBC, you can also write summation of Fx equal to 0 also, same thing. So FB will be equal to 25 root 2 kilonewton. So FB equal to 25 root 2 kilonewton. So we got all those P force member. Means member force when external load is applied. That is P force system. Now you have to calculate K force system. Now tell me, for determining K force system, you have to give one unit load in the direction of redundant, means from where you have released the redundant. So this is one, this is one. Why I have scored like this? Can you say? Because we have removed the member. The member is like this, and by default we are assuming that member is in tension. So force will be coming like this, and when you show it in joint, force will be like this. And since we have removed this member and we have to add one unit load, so in this joint and in this joint we are showing unit load towards each other, which is tensile in nature. When you are showing in joint, every time you try to show it outward, because we generally take tension to be positive and compression to be negative. Okay. Now here reaction will come, here reaction will come, here also reaction. Now check. This is one. When you will do at joint T, when you will draw the FBD, it will be 1. This will be KDC and this will be KBD. This will be theta. Now you see KBD will be equal to 1 cos theta. Cos theta is 45 degrees, so 1 by root 2. And this will be minus because KBD plus 1 cos theta will be 0. KBD plus 1 cos theta is 0, so KBD will be minus 1 by root 2. So this is minus 1 by root 2 or minus 0.707. Similarly, this will be minus 1 by root 2. When you come to this joint,
joint A. Yes.
You are telling something?
No, sir, no.
Yeah. We got this.
Yes, sir, KBD.
Now, see.
At joint A.
Now, first, we will there is more easier rather than to calculate every time. So 1, there will be some component in for this one, there will be some component 1 cos theta, that will be 1 by root 2. In this direction also it will be 1 by root 2.
Root 2.
Similarly, in this direction 1 by root 2 means I have decomposed that not unit load into x and y direction. Now you can see one thing. This 1 by root 2 at this joint, it is acting vertically downward, and this joint, it is acting vertically upward. So overall, in vertical direction, there is no force. Net force is 0. Similarly, in horizontal direction, net force is 0. That means this vertical reaction will be 0.
This horizontal reaction.
This horizontal reaction will be also 0. Means every reaction will be 0.
Okay.
Now, once all those reactions are done, you can calculate. We got this K member force for this member, this member. Similarly, now you can take this joint. You will find this member force, this member. Now again, when you will go to this joint, it will be minus 1 by root 2 outward or 1 by root 2 inward, 1 by root 2 inward, and this will be F not K BC. So KBC cos theta will be equal to 1 by root 2. Cos theta is 1 by root 2. So KBC will be 1 by root 2 by 1 by root 2 will be 1. So 1. We got K force system. We got P force system. Now the same thing. You have to again write it, note it down in table form or tabulate it and then calculate everything. I am writing it directly from my notes.
KL by AE, K square L by AE.
What is BC length? BC length is 3 root 2. BD. AE I am not writing because AE is constant throughout. It will get eliminated anyway.
20,000. Yes, sir. Yes.
P. So P force member we have to write. 0. AB member we got a 0. Where we have calculated 0 minus 25. and this was 25 root 2, 0, minus 25 and 0. K force minus 1 by root 2, minus 1 by root 2, BC was 1, AD was 1. This one we have assumed unit load along AD force. Sorry, AD member. BD is minus 1 by root 2. Everything is minus 1. Now you just multiply. This will come out to be 0. This will be 0. This will be 0. Now remaining will be 25 by root 2 into 3. In 75 by root 2. This will be 75 into 2 into 1. Everything is by AE.
It will be 150. Yes, yes. 2. That's why.
So what we are getting in total? How much?
75. 1 minute, sir. 1 minute.
Similarly, I am writing for this.
Two 56 by 8.
How much? 250?
56.06.
Okay. But let us keep it 256 only.
Okay, sir. Okay. 3 by
This will come out to be 14 point. How much? 14.5 by 8. So now check. This member we have removed. Initially, when this member was there any relative movement between joint A and D?
Yes, sir. Yes.
Was there any relative movement between joint A and D?
No, no, sir. No.
No. So from that, when you will remove under this 25 kilonewton load, there will be some relative displacement between A and D. And again, after deleting this external load, when we applied that unit load along that direction, that when we are writing that flexibility component, that is displacement along the member A and D due to unit load acting along the member A and D. You got it? That we got K square L by A. But the member force means we not assume, we took unit load and we calculated the displacement. But was the member force in member AD unity? No.
No, no.
It was FAD. Correct?
Yes,
So
sir.
FAD into displacement or relative displacement between joint or point A and D was 14.5 by AE due to unit load acting between that two joints plus due to external load We got 256 by A. That is the displacement. That should be equal to 0. Why 0? Because there won't be any relative displacement between this joint when this member AD was there. And that is the compatibility condition. From here, what you will get, if AD will be equal to minus 17.675 kilonewton. Minus 17.675 means B. Minus 17.67 kilonewton compressive. Because minus was there.
17.655.
You got this question, right?
Yes, sir. Yes.
When external indeterminacy is 0, then how to choose the redundant? Now, you can take this down because we have one more problem to solve. You can take this and try it because these are the question for indeterminacy that the previous class we have discussed. And the second question is from GATE 2019. So you can take this down.
Yes, sir. Let me take the screenshot. These questions are pretty much asked in engineering service. Means it is a very good question to solve everything.
Yeah, that's why I am giving. You
Yes, sir.
solve
Yes,
and
sir.
tell me the answer.
Right now?
Not now, you can tell me in the next class because we have one more question to solve and that is a lengthy one. After that, only our complete concept will be done. You can take this down because this is easier question. I want to show one more means question from when DSI value is 2 more than 1. You can take this down also. We will directly go to that question because I am giving the hint over here. See, determine the horizontal reaction at support A of the following truss. See, 4 reactions. I am doing it means giving hint in a very fast manner. So be patient enough and listen. There are 4 reactions externally, but you have 3 equations of equilibrium. So DSI external is 1, and you have to calculate the support reaction at horizontal support reaction at A, means this reaction you have to calculate. So take this as redundant. So when you take this as redundant, your primary structure will become like this. And there will be one reaction. Means this will convert it into roller. Now this is a statically determinate structure and stable in nature. So you can calculate all the member force due for this primary structure and keep it under P force system. Okay. Now remove all those external loads and apply 1 unit load in either direction. In this direction, in other direction, any direction you want, you can give and calculate the member force again for this structure only and keep it under K force system. Okay. Once that is done, nothing is left in the question. Again, you make a table. I am just giving it table over here directly. You just go and check it.
A, P, K, K, PL by A. A, C, C, B, D, E, 1, 2, 3, 4, 5.
So CAD, what is the value? 4 root 2. A value I am not writing, it will be 20,000 only.
20,000, yes sir.
KPL by AE, K
K
square.
square PL.
So we are getting P force member here as -5, -30, 5 root 2, -5. This was C was 35.3 -25 and 5. Now tell me, when you will take 1 unit force here, see, you have removed this external load and you have taken 1 unit force here. Now, check. 1 unit force you have taken here. So when you will take movement about any of these supports, A or B joint, you will get these reactions are 0 under this unit horizontal load. In this, when you are considering unit horizontal load, make sure you have removed those what?
External loads.
External loads. Because if you are taking into consideration external load, there your entire calculation will be wrong.
Everything
Now
will
once
be blunder.
This is 0, see, this is 0. So when you will do FBD for this joint B, this member will be a 0 force member. When you will go to this joint again, this member and this member both will be 0 force member. When you go to this point, this member will be 0 force member. Now everything is 0 in the topmost. Then 1 unit is acting like this. When you come to this point, this member will be 1 unity, member 4, this member force will be unity, and
1 unit.
1 reaction will come in this time. If you are taking inside, then this will be -1, -1. So you have to be cautious enough while matching your answer with any of the standard textbook. If the direction of unit load changes, then the K force system, the member force for this K force member will change.
Correspondingly change.
When you are taking 1, so we are getting these 2 as 1 and rest are 0. I am not writing. 0. And just multiply it, you will get the summation as 140. This will be -20, this will be -120, and this will be 4 and 4. 4 and 4 is 8. Both by AE. So now, this A joint in the main structure is static. Is it moving? Can it move in horizontal direction? No.
No, sir.
But when you remove that redundant, under this external load, it can move. And how much it can move? It will move by 140 by AE. That will be the deflection in horizontal direction. Plus, when displacement at joint A due to unit load at A in horizontal direction. What is the value? 8 by 8. But was our reaction that AX, is it unity? Did not be. It can be AX. So multiply it by X and it will be equal to 0 from compatibility, because this point won't move. So from here, what will you get? AX value will be 1735 by 2. 35 by 2, right? 140 by 8. 35 by 2 kilonewton. So it is 17.5 kilonewton. Option B. 17.5. Option B. And we are getting positive value. Positive value means what?
Your
When
assumption is right.
you will take one unit in the leftward direction, then only AX is positive. Means AX will come out to be 17.5 kilonewton positive in outward or leftward direction, outward to the truss. Outward in this sense, in this fashion.
Direction. Yes, sir.
This direction. Outward means this direction. Okay. You take this question, we will go to the last one. You take this question. Now here in this question, as we are taking AE to be constant.
Okay.
Everywhere. Here AE won't be constant. So I said at some point of time, here you have to calculate the absolute value for each and every part when you are calculating that KPL by AE. And summation and K square L by AE. So here you have to take AE part and do it numerically. Okay.
Okay.
This is the main question. With this, the complete concept of week 8 will be done.
Sir, what we will solve? The previous one or the next? This one?
This one. It has
Sir, please
two.
go back to the previous question. Okay, sir. Now you can move.
Yeah. Means in this question, the only thing is cross-sectional area are changing.
Cross-sectional area.
So you have to take this AI, not constant, but it will vary for each and every member. So you calculate AE for each and every member, divide it, calculate the numerical values, then add it, then what you will do? Write compatibility condition.
Yes, sir.
Then solve the redundant.
Here asked at support C. Okay.
See, if they are asking to determine what?
Horizontal reaction at support C.
So you will take which one as redundant?
Sir, that one force in the D point is in angular direction, means we have to decompose that too.
You can decompose na anyhow. That will be D cos 60, D sin 60.
Sin 60.
There is no problem in that.
Okay.
Any more problem here?
No, sir, no.
So I am going to the next.
Yes, sir.
Now, in this question, we have 3 bits. So we have to be fast. Tell me the DSI value. They are asking static indeterminacy. Members.
Yes, sir.
Joints. Reactions.
8/11 minus into 5. 12 minus 10 is 2.
2, right?
Yes, sir. Yes.
Till this point, every question has DSI value of what?
1.
Now we got DSI of
2.
Here with increase in DSI, the complexity of the problem will increase. Means you have to solve because your unknowns will increase. So obviously your complexity of the problem will
Increase.
So let us read this question, then we will solve.
To solve the problem, question number 7 using method of consistent deformation, we need to solve equation matrix. Here are a problem given in question number 7.
Question 7 is the previous question only.
Yes, sir. Yes. Assume vertical reaction at support A and remember force in member AD as redundant to get okay.
This is called as flexibility matrix. And F11 denotes displacement at 1 due to unit load at 1. F21 displacement at 2 due to unit load at 1. Similarly, displacement at 1 due to unit load at 2. Displacement at 2 due to unit load at 2.
Yes, sir.
Now, this D1L and D2L, can you correlate now what is D1L and D2L? Till this point, what D1L and D2L we are calculating there. I haven't given the name D1L and D2L there, but can you correlate now?
Redundant.
Now, D1L and D2L are the displacement at that joint after removing the redundant due to external loads.
Okay.
Means every problem we calculated this. This is D1L, means DL. There D1L and D2L are coming because we need to select 2 redundants there. Since here there was only 1 redundant, so 1 DL. So these values are DLs. That is due to external load. What is the displacement occurring at each displacement occurring at that point where we have removed the redundant. This 200 by AE is also DL. Similarly, this also is the DL of this question. Now here we have to calculate this F11, F21, F12, F22. So just do now when you will calculate F11, F12, F21, F22, there should not be any external load applied. So the structure will look like this, and the 2 redundants they have given. The first redundant should be taken as vertical reaction at support A. Vertical reaction at support A means it will turn to roller. So 1 reaction. The other reaction we have released, that is AY is redundant. Now one more redundant will come. That is in form of member force AD. That I will draw there because otherwise complication will increase. This joint was now. Now tell me what will be the value of F11? How to calculate F11? Your first redundant, that is first redundant is this one only. So you have removed AY and applied unit load along that redundant. I have taken vertically upward as 1 unit in the top upward direction. So what does F11 represent? Displacement at joint, displacement at 1 due to unit load at 1. Correct? Means you have to calculate displacement at this joint due to unit load acting at this joint only. So how to calculate? See, due to this unit load, we have removed all those external loads or external forces, this one. So after removing, we have only one unit load. When you come to joint D, these two members, you will get 0 force. When you come to this joint D, this member and this member. When you come to joint C, this member and this member will be 0 force. So only thing left is this member. And this member, when you come to this joint, draw the free body diagram. This is 1. This is F. So F plus 1 will be equal to 0. F will be minus. This F is F. Let it be F. So this is minus 1. So it will be K square. I am writing K1 square L by A. Why I am writing K1 square here?
Because there will be
2
coming.
2 DSI. So K1 represents that first redundant. K2 will represent the second redundant when we apply that 1 unit load. This 1 unit load, this K1 represents for first unit load, K2 will represent for the second unit. So this is minus 1 square. For every other, the member forces are 0. So you will get 0 square everywhere. Only the thing left will be for member A,
E,
B. So minus 1 square, length is 4 meter by A. So you got 4 by A. This is F11. For F22, you have to apply in which direction? Force, displacement along 2 due to unit load acting along that direction. Means displace here for this case, it will be relative displacement between these two joints due to unit load acting between these two joints. So this will be F22. This will be what it will be? K2 square L by AE. So now you check. When you come to this joint, this will be 0 force member. This will be 0 force member. You know, when you do summation of fx, this will come out to be 0. When you do, this will also come out to be 0. So once you have done this, you reached here. So you can decompose this 1 into
1 by root 2.
1 by root 2, and
1 by
it
root
will
2.
boil down to the same problem we have discussed earlier.
Earlier.
Now check. Horizontal and vertical both reactions means now you can delete this part. I am removing this part so that it will be easier to understand. This is 1 by root 2 and 1 by root 2. This is 1.
Okay.
Now you check. This horizontally and vertically both are balanced. So this member, this reaction will be 0, this will be 0, this will be 0.
0.
Now you can calculate this member force will come out minus 1 by root 2, minus 1 by root 2, this will be 1, this will be minus 1 by root 2, this will be minus 1 by
root 2.
Getting stuck. So now, so every member force you got, so you just sum it up. Minus 1 by root 2 square will be 1 by 2 length. For this one, the length is
4 meter.
4 meter by A. A I am not doing. In plus, for this one is also 4 meter.
Yes, sir.
So in this way, how many 1 by root 2 are there? 1, 2, 3, 4. So you have to write 4 times.
4 into 1 by root 2.
Plus, this 1 is there. So 1 square will be 1. 4 root 2. 4 root 2. This length will be 4 root 2.
Mm.
4 root 2, 1 into 4 root 2 by A, plus or into, one more will come. Can you name it? Why I have written 2? Or AD. We have given now
Yes.
1. So that will also come into effect. So now you got F22 as this. So it is coming out to be 19.312 by EY. AE, sorry. So we got F11 as 4 here. We got F22 as 19.31. Now, F12 or F21, that will be same from Maxwell's law or Betty's theorem. Anything you can put. Maxwell's reciprocal theorem. From there, you can get F21 will be equal to F12. So F21 represents what? Displacement at 2. Displacement at joint 2 due to unit load at 1. That means your structure is like this. You have to calculate displacement at joint 2. Joint 2 means your second redundant. Second redundant was like this. Due to what? Displacement at joint 2 due to unit load at 1. So unit load you have applied here, but you have to calculate displacement along this. You got it? You got it, right?
Yes, sir. Yes.
You got now. You are applying unit load here, but
Huh.
you have to calculate displacement along redundant 2.
Yes,
So,
sir. Yes.
so for this 1 unit load, you have calculated K1 force system. And you apply, you remove this 1 unit and apply this redundant 2 1 unit load. That will be K2 force system L by A.
A.
That will be summation. When you will do F12 also, that will just interchange K1 and K2 will interchange
K2.
their place. So they are same. So you just calculate for when there will be multiplication of K1 and K2, only one member force is non-zero. So you have to multiply that only. So you will get -1 into this is -1 by √2. Length is 4 by AE. So 4 by √2 AE. This will be 2.8 by AE. So option A. This is how you find the components or the each term of the flexibility matrix. Now, this is relatively easy because in this you have to find D1L and D2L. How to find D1L and D2L? Make the primary structure, apply the external load, remove external load, then apply unit load along that redundant and calculate K force system. Do summation of KPL by AE, means K1 PL by AE will give you the first one, and summation of K2 PL by AE will give you the second one. So now if you do K1 PL by AE, K1 for K1 system, you have only one member force which is has value.
Yes, sir. 4 by.
So it will be -1 into length is 4. But if the here you have to calculate due to this load P, external load 40. And after making this roller means primary support, what will you get for this member force? That is P force member. I am writing it. You just check it. You will get AB, right? AB will be 0. Yeah, AB will be 0 by AE. So you will get 0. So D1L is 0. So this option got eliminated. So you are left with C and D. When you calculate this summation of K2 PL by AE, now you know K2 values, K2 system you know, K2 force system you know. From here, you know all these K2 values, these K2 multiply with corresponding member force due to external load into corresponding length by AE. AE is constant here, so AE will be taken out. So it will be 2.8 sorry, it will be 169.3 by 8. 39 by 8. So option D.
Force in member AD.
Force in member AD can be calculated after you are done with this much. That is nothing.
Displacement.
You apply the compatibility condition. Now, what will be the compatibility condition? Can you tell? It will be D1L, D2L. This will be a vector plus F11, F12, F2, F22. This will be R1. R1 I am not. Let it be R1.
R2.
And this is R2. That will be 0 and 0. So see, when we have one redundant, so we are getting this only, means D plus due to unit load some F, only 1 and that reaction equal to 0. Now, this D1L is common, D2L is common.
Yes, sir.
Now F11, you applied, you need to calculate displacement at 1 due to unit load at 1. So you have applied unit load at 1, but that redundant, was it unit? It was not unit, it was some R1 value. So you multiply it with R1. Now this term is coming because this is displacement at 1 due to unit load at 2. You have two redundant. You applied another unit load at 2. But was that unit load real? We applied unit, but was that unit? No, that was R2. So you multiply that with R2. Then equate it and give compatibility at 0. 0 means for this case, those are hinge condition, it won't move, so it is 0. For second case, relative displacement won't be there because the member is rigid, so the second compatibility will also be 0, and in this way, this is the compatibility you need to satisfy. That's it from my side.
Okay.
So thank you. If you have any doubt, you can let me know now, or I can clarify your doubt. You can calculate this.
84. Sir, what is the meaning of actually axial rigidity? Means EI is the flexural rigidity. It defines the stiffness. What is axial rigidity? AE.
Flexural rigidity you are defining for flexor members will contain flexural rigidity. Axial members will contain axial rigidity. Now you tell me what is your question?
Sir, what is axial rigidity?
What is flexural rigidity?
The stiffness.
If you say stiffness, then what is stiffness?
Opposite of flexibility. Uh,
Then what is flexibility?
Resistance. Uh,
I have
Deformation.
defined flexibility in this class, so you should be able to define it now. Stiffness. See, stiffness means you have a member. Okay.
Yes,
You are
sir.
applying 1 unit displacement. To cause that 1 unit displacement, what is the amount of force that you are requiring? That is called stiffness.
Okay.
You got it right? Stiffness, suppose K. This is F by delta. So
Uh,
force required to cause 1 unit displacement is called a stiffness.
so F equal to K del means delta will be 1.
Now, when
Okay.
displacement will be 1, at that time, what
Okay.
amount of force you are putting, that force equivalent will be called the stiffness of that system. The opposite. When you apply 1 unit load, what is the displacement? That will be flexibility. The same thing we have defined now. Delta by F.
Yes, sir.
When you apply 1 unit force, what will be the displacement at that joint? That will be the flexibility. And this EI
F
and
by
A,
delta.
delta by F, it will be
Ah,
flexibility.
sorry. 1 by K. K. Yes, sir. Yes, sir. 1
It
by
will be
K.
1 by K. And this EI and AE is nothing but they define the strength aspect of the member.
Oh. That means both the flexural rigidity and the axial rigidity.
Axial rigidity define the strength aspect for axial members, whereas flexural rigidity EI is defined for flexural members like beams, frames,
These columns.
arches, yeah, columns.
Yes, sir. I have read the R.C. Hibler up to the second chapter. This week I
Okay,
will
that's
complete third
nice.
chapter. Yes, sir. Yes. And I have a doubt from stability and instability, but let me ask in the some another day,
Okay, fine.
because now everything is, otherwise everything will bounce. It's a 3 hour
It was,
long
I
lecture.
don't know how the class went
3
so
hours
long.
long.
It
Yes, sir.
went
Yes,
so
sir.
long because all those concepts are too conceptual and you cannot leave.
Yes, yes, sir. Uh, I think it is the best structural analysis class of the session. Means I told you in the last class, I have not studied anything, and I must say all the concepts that will come in the further for forthcoming lectures, that are most important for the competitive exams aspect. Means the
From this, from previous to previous week only, we started the original structural analysis. Before that, it
yes,
was like mixture of statics,
everything.
engineering mechanics, SWAM, structural mechanics kind of thing. The basic analysis part came once we started means indeterminate structure. And
Yes, sir.
indeterminate
Yes.
structure will take too much of time compared to determinate structure, because determinate you can directly do using equations of static equilibrium. But here you have to think how you can apply the compatibility, how you can apply all those means
Yes, sir. Yes, sir.
methods we have to get all those solutions. Once the solution is done, that is easy. Anyhow.
Yes, sir. Means slope deflection and moment distribution methods are frequently asking in the engineering service exam, and this unit load particularly, it was very tough one.
It will be tough if you don't practice.
Yes,
You
sir. Yes.
just go, sit down, practice some questions, n number of questions, then it will means automatically the algorithm means you will get accustomed to the system. What is happening, how is happening, like this. Means just in 5 steps, you can just summarize the whole 3 hours
Oh,
lecture today.
yes, sir. Yes.
Make the statically indeterminate structure, determine the DSI.
Yes, sir.
Once the DSI is determined, remove all those redundant forces, means identify those redundant forces.
Forces.
I am not talking about movement because these are truss members, so axial members, only forces. Identify the redundant such that the primary structure is what? Stable.
Stable.
Once that is done, apply the external load, calculate
Yes,
the
sir.
deflection at that joint where you have chosen the redundant.
Yes, sir.
Once
Then
that
unit.
then you apply a unit load one at a time. If there are more, one at a time. You have to
Yes,
apply
sir.
unit load one at a time, not both or not
Yes, sir.
all
Yes.
at a time. It is like a incremental process. You have to do it sequentially, not at a time, simultaneously. You have to do sequentially. Once you are done, you put one, calculate the deflection at that point, ask the question, is my force or is my reaction unit there? The obvious
No,
answer
sir.
is
It
I
was.
don't know. It might be unity. It might not be unity. Who knows? I only know that is a unknown. Some A, B,
Yes.
C, X, Y, Z. I know only. Let it be C. Multiply it with
Okay.
C and see the compatibility. If that joint can move or not. There might
Okay.
be some questions. Their lack of fit problem will be there, or support settlement will be there. In that case, if there is some support settlement or lack of fit, then that they will mention that the member is 5 mm too long. Then that 5 mm should go into this matrix. This plus this should be equal to 5 mm.
Acha. I think that will encounter in the slope deflection method or
No, that
something.
can be incorporated here also, but
But it will be too long.
I haven't taken it because anyhow, for this much question also it took 3 hours.
Yes, sir. Yes, sir. It will be too long if I support
Hmm.
settlement will be incorporated.
Ah.
But I have not seen for force method support settlement. I have seen only
You
the
will
slope
see in
deflection.
the next class when you will discuss about the next force method. I will take an
Three moments
example
theorem.
where. Ah, ah,
Yeah, it can be there.
ah.
But if in
Here, support settlement might not be there, but lack of fit can be there in trust. Lack of
lack of,
fit means during fabrication.
yes, yes, yes.
Here, here we are writing 4 meter length.
Huh,
It might not be 4 meter. It might be 3.995 meter, 996 meter. That shortening will induce some internal stresses in the members. That internal stresses will be
the
accommodated where? here, because anyhow our structure is in the state of equilibrium, no?
Ah, sir, yes, yes. The concept belongs to pre-stress, misfit or lack of fit, pre-stress, pre-strain.
Pre-stress is altogether a different
Huh.
means different thing. So I don't want to intermix pre-stress concepts here.
But the concept is heading towards that point. The pre-strain means misfit or
Pre-stressing, those are tendons and all things will come into picture. Means they
yes,
are deliberately you are doing. Here during fabrication there is a error.
okay, okay.
Means doing it intentionally and doing it deliberately and doing it unknowingly, there is some difference, na?
Huh.
You are going to a exam in a hurry, you did a mistake. Have you, if you come back home and will you say I have done it intentionally?
No,
It's by means that pressure came into picture during that hall exam day, so it was unintentional.
yes, sir, yes.
Similarly here, that when fabrication is going on, the machine is producing the parts. Who knows? There might be some error, manual error, machine error. There are many kinds of error are there. It can happen that machine did some error and you got some change in length. So that was unintentional. But when you go to pre-stressing, you are inserting some tendons, you are jacking it both ends, you are applying some force. That was intentional.
Okay, sir. Okay,
Okay.
okay, sir. Thank you
Any
so
more
much.
doubt?
No, no, sir, no, sir. Next class.
Okay, fine.
Thank you.
Bye. Good night.
Good night.
You just calculate the last question.
Yes, sir. I will revise everything because these
Yeah.
are very important questions.
Yeah. Okay.
Sir, you please send me the book PV and Roy. What I have. Okay, okay.
I have given to you. Means let me stop sharing. Otherwise.
Huh.